5.
That big bulbous drooping nose, the twin rear-mounted engines and the high T-tail. If it's not the world's best-looking airliner, it's certainly one of the most easily recognizable. We're about to fly from London to Stockholm with Captain Hans Ackerstedt of SAS on the flight deck of what's become an aviation classic, the Douglas DC9. The story of the DC9 and its present-day derivatives began in the early 60s. Douglas, like other manufacturers, realized there was a need for a new breed of jet airliner, able to operate from small airports with relatively short runways. Europe, it seemed, had already developed new designs which could handle the job. The French-built Caravelle, the first airliner to have engines mounted at the rear, impressed Douglas so much they began trying to sell them in the States. But the tricky maintenance, the poor cargo capacity, to say nothing of the quirky Gallic instrumentation, kept buyers away. There was only one alternative for Douglas, to develop its own small twin jet. A potential competitor was the British BAC 111. It too had rear engines and another new touch, a tailplane at the very top of the fin. This was a feature which turned out to be a potential problem.
There is one disadvantage to having the tailplane on the top of the fin, and that is that if the aeroplane gets into a stall, which of course is a very dangerous condition which pilots try to avoid, then the turbulence from the wings completely washes out the effect of the tailplane, and it effectively puts the aeroplane out of the pilot's control because he's got himself into a stall. And because of all this turbulence negating the effect of the tail, he can't get himself out of it. So when you put your tailplane on the top of the fin, you have to design the aeroplane very, very carefully so that that situation cannot occur.
When the first DC9 was rolled out, it was clear Douglas had learned from the design shortcomings of its European rivals. The T-tail was of improved design. There was plenty of cargo space, and the rear-mounted engines had more power than the Caravelle or 111. But the commercial risk for Douglas was now considerable. Boeing was working hard on its new short-runway airliner, the 737. The DC9 had to be the first to fly. On February 25, 1965, came the crucial test.
The DC9 is a twin-jet transport, a little smaller than most of the current crop, designed by the Douglas Company to carry 80 passengers and 3 tons of baggage on high-speed, short-haul flights from 100 to 1,500 miles. Fully loaded, it will land or take off on short runways, 5,000 feet or so, which will bring jet service to the average small airport. Loaded today with test equipment, all systems working, the short runway capability was demonstrated when the first DC-9 to fly took off from Long Beach on its first flight test. Engineers claim this first flight test was an unqualified success. Airborne for over 2 hours, the new plane finally landed at Edwards Air Force Base, where it will undergo a continuing series of flights. It will soon be joined by 4 other DC-9s in an effort to shorten the schedule. The competition, Boeing 737, is expected to begin flying by the 1st of next year. After today's success, Douglas hopes these new $3 million jets will be in commercial service by that time.
In fact, Douglas had no order when the DC-9 was first built. They had no Pacific order. There was the promises in the right-hand column, but no firm orders. And they built, I think they built 3 prototypes, and they were evaluated. And then Mr. Douglas, Sr., talked to the chairman of Delta, who was an old friend, and Delta ordered the first 15.
That modest start was enough. Soon other airlines began placing orders too, and asking for longer versions with more seats. In 1967, the DC-9 Series 40 made its first flight, one of a score of variants of the original model. This version, 20 feet longer than the first DC-9, was destined for SAS, Scandinavian Airlines. SAS is still one of the largest operators of the DC-9. Our flight to Stockholm is on board one of the airline's DC-9 41s, a version specially developed for the airline. In SAS, it's the ground engineer who carries out the walk-around, the vital outside check made before every takeoff, to make sure the aircraft's safe to fly.
You start from the nose and you follow the aircraft, the contour of the aircraft, the wings, to check there haven't been any holes in the aircraft or no damage and no obvious leak or something like that. And you continue. You have to check all the panels. And you are trying all the time to get just a general overview of the airplane.
While the outside walk-around is being completed, the flight plan and the weather are being checked by the flight crew, Captain Ackerstedt, and his co-pilot, Klaus Renninger.
We'll fly through an area with fairly good weather all the way. We may have a fairly good tailwind as we have a jet stream up at 10,000 meters. Otherwise, there's no significant weather on the route to Stockholm. We will have a takeoff weight of about 48 tons. That's almost maximum takeoff weight.
With all the luggage loaded and all the passengers aboard, Captain Ackerstedt and his crew are ready to ask clearance for the DC9, now designated Scania 1532, to be pushed back from the terminal's departure gate, Juliet 10.
Scania 1532, we're at Juliet 10, let's push. 1532, good afternoon, your pushback is approved. Push approved, Scania 1532.
Up to now, the DC9's small auxiliary power unit has been providing all the onboard electricity. Now it's time to fire up the main engines. With ignition on, a pneumatic starter motor, controlled from the overhead panel, winds the engine up to starting speed. When it's turning over fast enough, the captain moves a lever to pump fuel into the turbine's combustion chamber.
Fuel on. Fuel flow and
EGT is the measure of the exhaust gas temperature, the indication that the engine has fired up and that the temperature is climbing. Once the dials show the engine's running smoothly, the process is repeated on the second engine. With both Pratt & Whitney turbines at taxiing power, the aircraft begins its journey to the runway.
Check the norm, check the
So now we start taxiing out to runway 27 left at Heathrow. That means taking off to the west. Then we will turn around over London City and fly northeast to Stockholm.
1185, goodbye. 1185, goodbye, 2805.
Now we are leaving the tarmac area. We are entering the runway areas, so we are switching frequency to another controller.
The controller reminds us we're behind a United Airlines Boeing 767.
Depart, correct staff, the United 767 depart, line up runway 27 left. Behind the United, line up runway, Scania 1532.
Behind the United line up to the left. And that's United Airlines Boeing 767, which is fairly heavy, so we have to wait a while after he has taken off to avoid the turbulence behind. On the ground, I'm maneuvering the aircraft with the nose wheel. I'm steering the nose wheel with a wheel here on my left side. So this is runway 27 left at Heathrow. It's 4,000 meters long, which is much more than we need.
Scania 1532, take off runway 27 left, service wind 250, 13 knots.
That's it.
Clear for takeoff, Scania 1532.
Okay, timing. Runway and combat check.
For most takeoffs, 25 degrees of flap is selected to increase the lifting power of the wings at low speed. Despite the maximum weight, only 92% of full power is needed for takeoff today. The co-pilot monitors the gathering speed, advising the captain as V1 is reached. That's the point at which we're committed to takeoff, and VR when it's safe to rotate or pull back the control column. All twin-engine jets have to be generously overpowered so that they can take off safely even if one engine fails. But the takeoff performance of the DC-9 has always been impressive. The DC-9-41 has high-lift wing devices and specially upgraded Pratt & Whitney JT8D engines, delivering 16,000 pounds of thrust, a huge reserve of power which allows it to attack the sky with a pace which leaves other airliners standing. At ground level, though, the takeoff noise can be high, and some less well-maintained DC-9s also had a reputation for ignoring the rule, no smoking on takeoff. A novel solution was imposed by the Swedes at Stockholm Airport. A special carbon tax was imposed on polluters. Now only the clean jets can afford to fly there. At 6,000 feet, Captain Arkerstedt lets the autopilot take over.
I'm engaging the autopilot.
The autopilot now keeps the aircraft on course and controls the throttles to maintain the correct airspeed. The autopilot has been set to take the aircraft to its cruising altitude and level out on the heading the captain selected. Airspeed is now 450 knots, about 500 miles an hour. 20 minutes after takeoff, an orange light indicates that the aircraft is within 1,000 feet of completing its climb to cruising altitude 33,000 feet. Destination, Stockholm.